Greetings, random viewer. Today we're going to have a look at this sample and hold module on stripboard. There are three separate outputs, one stepped and two with glide. At the top we have a clock in, external sample in and three outputs. There's the rate knob, two glide knobs and three separate level outputs. Okay, if you're squeamish, look away now. Let's have a peek behind this, and there you can see it's quite a mess. There's the three boards there, all cobbled together. Please do a better job than that, which shouldn't be hard. Okay, so as I said, there's three boards. The first one being this noise section. This is from a Ray Wilson design. I wouldn't be too concerned with that 10K trimmer at the bottom there. That's to adjust the symmetry of the noise output. I don't have an oscilloscope, so I couldn't check it. But if you take the noise into the sample and hold, you might be able to do it by ear to adjust to get some kind of symmetry in your randomness, if that makes sense. You can also emit that output attenuator, as I will just take that straight into the sample and hold section, which we're going to have a look at next. Okay, so let's have a look at this sample and hold section here. Now I'm not using a common circuit using an op-amp and a JFET, I think it is. There's a custom chip here, the LF398, which is ideal. It's not the cheapest of components, but nevertheless it's ideal. So we're going to take the noise output and go into pin 3 there. Now if you want to use an external signal to sample, i.e. the LFO, then you're going to need a switched jack. If you don't understand how this is working, just have a further look into how the switched jacks work. And I've noted there where the tip of the jack goes. So that's the input there from the noise. Now I had to put the 3904 transistor in there to drive the LED. I noticed when I was using an external clock I was having problems with that LED, so that worked out pretty well. Also at the top there, the timer for the rate, please use a CMOS or low power 555 timer. The more common 555 timers will induce noise into your circuit, and they really aren't ideal. And I've also noted to use a Weimer cap for the hold section. This is the part that holds the voltage that you've sampled, and I've tried electrolytic capacitors, ceramics. I even bought some polystyrene caps. They just wouldn't work. They wouldn't hold a steady voltage, and I found these Weimer caps to be far more superior. So it's up to you if you want to experiment, but I thoroughly recommend using them. Now let's take the output from the sample and hold section, and we'll take it into this final board, which is the glide section. So I'm using all the inputs outputs on this 074. So let's have a look. We have one input with three kind of separate outputs. One is a stepped output with no glide, and the other two have separate glide controls. I think that's pretty straightforward there. The out 1, 2 and 3, yeah, they can all have levels on them, say 100k attenuators, and that will give you individual control of all the outputs. Well, I hope that makes some kind of sense. You might have to work on it, you might learn stuff, you'll probably make mistakes, but nevertheless, stick all these boards together and you have a pretty good sample and hold module. Thanks very much for watching again, and I hope to see you again soon-ish.